Mercado math, it's time to do some math. Let's Merca do it. Hi kids, and welcome to my basement. No, that didn't sound right. Hey kids, glad you get to spend time with me in my basement. Rattling, that wasn't better. I'll just cut this out and try again. Hey, let's do some math. Today we are going to be talking about radical equations. Now, I'm going to give you the most basic one up here. It's a very simple idea, and just you can keep adding to it and make them really kind of crazy. But to be realistic, they're not going to get much crazier than what we do here. So the most basic idea you can imagine is a radical equation. So I'll give you one that looks like this. Radical equation. Square root of x equals 4. Now, a lot of you are smart enough to probably just look at this and go, it's 16. Because you know your perfect squares. But I want to talk about the logic behind this. Your goal, as it's always been when you solve an equation, is to get x by itself. The issue here is x is not by itself. It doesn't say x, it's the square root of x. So you have to get rid of the square root. The way you get rid of a square root is you do the opposite operation. You square it. That's the opposite. The opposite of addition is subtraction. The opposite of multiplication is division. The opposite of square root is squaring. So you square it. Whatever you do to one side, you do to the other. I'm going to square this right side also. And now, what happens is, if you're square to square root, they kind of cancel each other out. It's like adding 2 and then subtracting 2. They kind of just negate each other. So you square to square root, this kind of just negates itself. You're left with an x equals 4 squared is 16. Now that's a very basic version of this. Still very important to do, but very basic. I will give you another one now. It should make a little more, should look a little more like algebra. Alright, so this is another one that's still simple enough that a lot of you might be able to look at and figure out with a little bit of time. Because like I said, ideally you realize the square root of what number would be 5, so you can kind of play that game. But once again, I'm going to try to get x by itself. Here's x. Your goal is to get x by itself. The way you do that, get rid of all the other crap that's with it. I can't get rid of this plus 3. The problem is plus 3 is trapped under this square root, so you can't get rid of it yet. In order to get rid of that 3, you got to get rid of this square root. How do we get rid of a square root? You do the opposite. We square it. Whatever you do to one side, you have to do to the other. This should all sound very familiar because it's what you do when you solve an equation. It's just, people only think of addition, subtraction, multiplication, division. Square root, that is an operation. So from here, the idea, you're squaring a square root. They're opposite operations. They kind of just cancel each other out. You don't have to cross it out. I like to just show you that. And now what's left is this x plus 3. You got rid of that square root. You have an x plus 3 remaining. Equals 5 squared is 25. You can already kind of imagine the common mistake's going to be forgetting to square the other side. There'll be a lot of x plus 3 equals 5. That'll be a normal mistake. If you do that, you're normal. Don't feel bad. If you do it a bunch of times, then you're just not paying attention. Solve an equation. To get x by itself, we're going to do minus 3 minus 3. That's gone. You get x equals 25 minus 3 is 22. And that should make sense, because if you plug in 22, 22 plus 3 is 25. Square root of 25 is 5. It should all kind of go like, yeah, I probably could have got that without all the algebra. However, keep in mind, these are still not what I would say difficult ones. So yeah, a lot of you I think can do this in your head because these aren't anything crazy yet. So here's one that has a little more going on. You still want to get that x by itself. In order to do that, you have to get it out of this square root. We can't square everything yet. Technically you could. It'd be very, it's a little more advanced than we really want right now. But you can technically square everything, but you would have to include this 5, and it wouldn't be as simple as just plus 25. So the smartest thing to do, the only thing you should really do at this point, is get this square root by itself. That's really all you should be doing. Unless you're, like a prodigy and you already know how to do all this. But that's going to screw up a lot of people if you try to do it. So the way we get it by itself, you're going to get rid of that 5, minus 5. You are now left with the square root of 2x plus 3 equals 3. And now this is a similar type of setup that we had in the last problem. The x, it's trapped under the square root. The only thing on this left side now is the square root, which means I can square it. Whatever you do to one side, do to the other. Remember, squaring a square root, these kind of cancel each other out. So you're now left with a 2x plus 3 equals 3 squared is 9. Makes you feel better. You can cross those out. You don't have to. I'm just doing it for a visual. Now we got a x over here. We want to get rid of this minus 3. Minus 3, you have a 2x equals 6. Divide by 2, divide by 2. You get x equals 3. That's done. You can plug it in, kind of see if you got it right. Just plug it in, see what happens. If I plug in a 3, 2 times 3 is 6. 6 plus 3 is 9. This is the square root of 9. The square root of 9 is 3. 3 plus 5, yeah, that's 8. I feel good about this now. And like I said, there's nothing wrong with checking your answers, especially if you're home and you have quizzes. Why the hell wouldn't you want to check it? Take the little bit of extra time and just see what works. So here's one that people don't really figure out how to do it on their own. This is one that really, you might get the first step and then people kind of struggle. A lot of times, the other ones we did, some of you, I think, probably figured out how to do that on your own. This is going to be one that once you see it, you're like, oh, I guess that makes sense. But this is the one, well, we'll do another one after too, because these are the harder ones. So you're still going to do what you've been doing. I want to get the square root by itself. I'm going to square whatever I do to one side, I do the other. You want to get x by itself. The issue, there are 2 x's now. And you're going to see what's going to happen pretty quickly. The square root and the square cancel each other out. You are now left with 6x minus 8 equals x squared. This is where, if you've never done this before, people get hung up. And it becomes a little more difficult. So, the moment you see that x squared, you should kind of have like flashbacks to factoring. If you see an x squared, you're probably factoring. If the key thing when you were factoring, it always had to be equal to 0. So we're going to get this equal to 0. I'm going to keep that x squared there. I'm going to move both of these over. I'm going to do minus 6x and a plus 8. Minus 6x and a plus 8. These will cancel out. I now have 0 equals x squared minus 6x plus 8. And then you should be going, oh, crap, that again. This is what I always called basic factoring. This was the most common one. This is the one we do a lot of. It's also probably one of the faster ones if you know your times table. Things that multiply to give you 8. There's 1 times 8 and 2 times 4. You want a positive 8. How do you get positive numbers? They could either be positive, positive, or negative, negative. You want them to add up to a negative 6, which means you want that negative, negative, which kind of looks like a dead cow if you remember. The negative 6, negative 1, negative 8, that's not going to give me that negative 6. Negative 2, negative 4, there it is. This factors to 0 equals x minus 2, x minus 4. If you also remember, this actually is not my answer. This is what almost gives me my answer. Zero product property. Something times something equals 0. One of these has to be 0. So, you solve the 2 equations. This is something I think a lot of you can do in your head. X minus 2 can equal 0. And for this one, x minus 4 can equal 0. Deep down, like I said, I think you guys can do that in your head. Let's chuck that one. Plus 2 plus, you get x. Let's just break the one set. X equals 2, x equals 4. And I have 2 answers. Or do I? You do have to plug these in to check them. This is going to be the sort of problem where you do work sometimes, it's not always going to work out that they both are correct. You have to check both answers every time. Sometimes they'll both work, sometimes only one will work. So let's plug it in, see what happens. When I plug in 2, 6 times 2 is 12. 12 minus 8 is 4. This is square root of 4 equals x, which is 2. Yeah, that works. 2 is an answer. I still got to check 4. Even though I know 2 works, I have to check 4 to see if that works also. 6 times 4 is 24. 24 minus 8 is 16. This gives me the square root of 16. Equals x. The x I was checking was 4. This also works. These are both correct answers. I can keep them both. Once again, not always going to work. Like in the example I'm about to give you now. Alright, so kind of similar to the one we just did. Let's just review it. We're going to be doing the same exact steps. I basically want to get this square root gone so I can get this x out. So to get rid of this square root, I'm going to square it. Whatever you do to one side, you do to the other. These kind of cancel each other out. I am now left with an x squared equals 4x plus 12. The moment I see that x squared, I'm thinking factoring. And like I said, factoring is coming back in a big way, guys. There's x squared. I'm going to get all this equal to 0, so I'm just going to move all this over. Minus 4x minus 12. Same thing here, minus 4x minus 12. This gives me x squared minus 4x minus 12 equals, and all that's canceled, 0. There's my new equation, and this is factorable. Things that give you 12. 1, 12, 2, 6, 3, 4. You want a negative 12. That means 1 is positive, 1 is negative. You want them to add up to a negative number, a negative 4. And if you remember how adding and subtracting works, you subtract and keep the dominant sign, which means you kept the negative. The negative was the bigger number. The negative was dominant. It won the fight. So negative is my bigger number. Negative, negative, negative. Which one gives you negative 4? Nope. Yep, there it is. 2 and negative 6. From here, I'm going to go x, that's a positive 2. That's the negative 6. Equals 0. And like I said, I want to believe that you guys can kind of just write the answer from here, but we're going to make sure and double check. I'll write the equations. X plus 2 can equal 0, and x minus 6 can equal 0. If you remember the reason for that, it's the zero product property. Something times something equals 0. You know one of them has to be 0. It's basically like a magic trick. And you get your 2 answers. I get x equals, this would be negative 2, plus 6 plus 6, 6. I have to check both of those answers, okay? Because like I said, it's not always guaranteed they are going to work. So I'm going to plug in this negative 2. X is negative 2, so I get negative 2 equals square root. And to be honest, the moment I wrote that, I'm like, no, this isn't, and we'll go over in a second, but that's a hard no already. 4 times negative 2 is negative 8. Negative 8 plus 12 is 4. So that is my equation when I substitute, and that is wrong because the square root of 4 is 2. Not negative 2, 2. This is not an answer, okay? This screwed us up. This is impossible. Remember, if you understand imaginary numbers and all that, you kind of know what's going to happen. But square root of 4, not negative 2. I'm going to plug in that 6 to see what happens. 6, there's x. X is 6. Equals square root. 4 times 6 is 24, plus 12, 36. I'm like, yeah, square root of 36 is 6. That's an answer. There it is. X equals 6. Not 2. X equals 6. All right? Okay, guys, and that's kind of the end of the chapter. And to celebrate, let's see what I'm going to draw. celebrate the end of the chapter on radicals, I drew a radish because you guys did a rad job. If I'm being honest, you did okay. You might even say you did a rad-ish job.